In this video, we're going to look at solving trigonometric equations, but some more complicated ones. In particular, when we have one like this, where inside the trig function, we don't just have theta, we have 2 theta. So if we're trying to solve sine 2 theta equals 0.55, for the domain theta is between 0 and 360, we first of all need to think about what sine 2 theta looks like on that domain. So let's draw a sketch from 0 to 360. And remember, sine 2 theta, well, the 2 there means that we have 2 whole sine curves in the domain, in what we would normally only have 1. That is, the period is a half of what it normally is. The period is only 180. So here, sine 2 theta goes up and down like sine, but instead of it doing it every 360, it does it every 180. Makes this one 90, this one 270, and this final one 360. Now if we look at this, we can see, where is that equal to 0.55? Well, that's about coming across here. So there's going to be 4 solutions to this question. There's going to be 4 solutions for theta for this question. How do we actually go about finding those? Well, we do a similar process to what we did in the last example of the previous video. And we say let phi equal 2 theta. That means we have sine of phi is equal to 0.55. And if sine of phi is equal to 0.55, we can do sine inverse of 0.55 to find a value of phi, which gives us 33.37 degrees. So now we need to find the other ones that work for phi. But we need to be careful here, because this is sine of phi, not sine of 2 theta. Our graph above was for sine 2 theta. So we need to think, actually, what does sine of phi look like? Let's be a bit more specific here and label the axes. This one here is for theta, and this one we're going to do for phi. And we can see if we have this one, we actually have the much longer one, the more spread out one, the stretched version, or the original version, I should say, which goes through like that. So we know that when phi is 33.37, we get the value we want, which means by symmetry, we can find the other values for phi. So the other value for phi will be 146.63. But we also know that we need 4 solutions, because we saw that in the graph above. So actually we need some more solutions. But because we know sine phi is periodic with 360 period, we can just add 360 to the 2 results we've already got. So that means our solutions for phi are 33.37, 146.63, and then 360 onto each of those, 393.37 and 506.63. Now we can go back and solve for theta, because we know that theta is equal to phi over 2. If phi is 2 theta, then theta is phi over 2. So that gives us our final answer of theta is equal to, well, it's a half of each of these. So that's 16.69, 73.32, 196.69, and 253.32. And there are our 4 solutions that match up with the 4 solutions on our first graph. Let's have a look at a couple more examples of this. Here, cos of theta over 2 is minus 0.16. So the first thing we're going to draw is a sketch of cos of theta over 2 for 0 to 360. That means the period has doubled. So that means we don't actually even see the whole cos graph. It only does this in that 360. So it goes through 180 here and then finishes at 360. So it's been stretched by a factor of 2, or the period has doubled. So how many solutions are there? Well, we can see on this graph that for 0.16, that's coming across here, in that domain, there's only actually one solution. So now we let phi equal theta over 2, and we've got cos of phi is equal to minus 0.16. That means phi is equal to 99.21. We know there's only one solution here, so we don't need to find any more. We know this is the only one we're interested in. So now we go back and we say if theta is equal to 2 phi, which means that theta is equal to 198.42 degrees. Have a look at the next example. In this example, it's a bit more complicated again. The first thing we need to do here is actually rearrange the equation so that we've only got sine. So we need to rearrange it so that it's 5 sine 3 theta over 4 equals minus 4. So sine of 3 theta over 4 is equal to minus 4/5. So now we're going to sketch sine of 3 theta over 4 on the domain 0 to 360. Now this one's a bit more complicated to sketch what 3 theta over 4 looks like. So actually we're going to go about this a slightly different way for this one because it's a bit more complicated. And we're going to go straight into the let phi equal 3 theta over 4 stage. So that means that sine of phi is equal to minus 4/5, which means that phi is equal to minus 53.13. And what we're going to draw on the domain this time is actually sine phi. We're just going to use this one. And in that we have this. And here we've actually got the one down here that we're given. We draw the line through. That's the one we've been given. We need to find the other ones. And we can see by symmetry we get that phi is also equal to 233.13 and 306.87. Now we've got 3 results for phi that we might possibly need. Now we're going to use the fact that theta is equal to 4 phi over 3 to find the values for theta for each of these. And, well, we know the first one is not going to be in our range because it's negative, so we definitely can't use the minus 53.13 because timesing that by 4/3, it's still negative, so we don't need that one. The 233.13, when we put that in to this, we get 310.84 degrees. And when we put the 306 one in, we get 409.16 degrees. What we notice here is actually that second one is outside of our domain. So again, we don't want that one. The only one we want is this one here. Now you could have done this in the same way as the previous ones by sketching sine of 3/4 of theta and finding how many solutions there were in the domain. That would have been fine. It's just a bit trickier to sketch sine of 3 theta over 4. So rather than go about that and maybe making a mistake, this way we can find extra ones and just remove the extra ones at the end because we know we don't need them because they're outside of the domain. Finally, let's look at example 4. This time we've got 2 theta plus 60 within the cos. And we're going to do the same kind of thing here. Rather than sketching cos of 2 theta plus 60, which we can do, we are able to do that, where we're just going to sort of go the more ad hoc way. So we're going to say let phi equal 2 theta plus 60 degrees. That means we're dealing with cos of phi is equal to minus 0.15. And that gives us that phi is equal to 98.63. We now consider what cos of phi looks like. Cos of phi looks like this. Comes down and back up. When is that equal to minus 0.15? Well, that's down here somewhere. The first one being the one we've already found. The second one, another one. So possible values for phi here are 98.63. Using the symmetry we get 261.37. And then we can add 360 onto each of those as many times as we need. And that actually gives us 458.63 and 621.37. From here we now want to find theta. So theta, rearranging this, is phi minus 60 all over 2. And when we do that to each of these values, we get 19.32 degrees, 100.69 degrees, 199.32 degrees, and 280.69 degrees. Well, maybe we need to check another one. We could add another 360 onto the 458. But if we do that, we actually get a value that's outside of our 360 domain. So it doesn't work. But we should still check that one to see if there are any more. So if we add on 360, 458.63 plus 360, we get 818. And if we minus 60 and then divide by 2, we get 379. So it's close. It's only a little bit too far, but it is a bit too far out for what we want. So here we can see that those are the only 4 options. By performing that check at the end, we didn't need the last one. You should always check to see if the next one will fit in. So that's how we can solve some more complicated trig equations. We can go about it by sketching the graph first and finding how many solutions should there be, which gives us an idea of exactly how many we're looking for. Or we can go this more ad hoc way, where we keep adding on 360, we keep finding all the possible ones there could be, until we see that they go on too far for our original theta. In either case, we let another letter phi, we've used here, equal what's inside the trig function to make the calculation easier, and then undo that at the end to find the values for theta.